Hello everybody, my name is Mohan Deshpande, and in this video I want to show you guys how we can apply brightness and contrast to an image using OpenCV. First things first, I have to import CV2 and I have to load in my image. So cv2.imread test.jpg. Okay, so now that my image is loaded, now I have to find some way to apply brightness and contrast, and if you remember, we discussed how we can use that kind of weighted sum thing, and that's because OpenCV actually already has a function called add weighted, and that actually does that exact weighted sum. So we just have to substitute in appropriate values. So first thing that I'm going to do is declare a variable to store the output image. So I'll just tell this something like cb_img for contrast brightness equals cv2.add weighted. And now the first thing it needs is the first image, I sub 1. Then the second thing it needs is the alpha that will be multiplied by that. In other words, that's the contrast. So let's pick a contrast value like something high like 4, for example. And then here's where we need I2, but we said that because we're going to select the beta such that beta is 0 and it's going to cancel out I2, mathematically that works out, but programmatically we actually do need to give OpenCV an image here. And so you might be saying, well, does that mean we have to load up another image or something? And no, you don't. Turns out all OpenCV needs to perform this is an image with the same data type and same size as the first image. And if you remember, that's because this weighted sum is scalar multiplication and matrix addition. So in order to add two matrices, they have to be exactly the same dimensions. And OpenCV puts the additional constraint that they also have to be the same data type. By data type, I mean data type of the element. So that can change depending on, but we're not going to go into that. So a quick and dirty way to do this would be just to copy this original image. Image.copy. And so this is guaranteed to have the same dimensions and data type as this image here because it's a copy of the image anyway. Okay, so that handles that. Now it's not the most efficient way to do this. There's a better way to do it that I'm going to get to towards the end of the video. But anyway, next is the beta value, and that's 0, and that's going to kind of nullify this. Okay, and the last thing is that gamma matrix, and as it turns out, OpenCV will actually create the matrix for you with the appropriate dimensions. You just have to specify the value that is going to be in each of the entries of that matrix. So this is the brightness. So let this be something like, I don't know, 100. Okay, and that's it. That's really it. One line of code again. Thank you, OpenCV, right? One line of code, and we can apply both brightness and contrast. Super simple. Let's actually see what this image looks like, though. cv2.imshow. We'll just show the image. So cb_img, and then we'll do the same stuff with wait key 0 and destroy all windows. Excellent. So let's just go ahead and run this. And you can see that indeed contrast and brightness has been applied to our image. And you can see this very clearly here in this image. So obviously the contrast is set pretty high and the brightness is also set pretty high, which is why we get this image that's, has a lot of white pixels. Okay, so that's how we can apply contrast and brightness to an image, but like as I mentioned before, there's a more efficient way to do this matrix B, because image might be, very complex or a very large image, and as it turns out, we don't want to have our computer store all of these values. So there's a nice way to do this so that we can be a little bit more conscientious of space. And basically how we can do this is we create a matrix full of zeros. And this is good, this is better because zeros this is what's called a sparse matrix basically, and they're like quicker, more efficient ways to represent sparse matrices than there are to represent like full color matrices like these. Anyway, so to create a matrix like that, we can use NP, NumPy has a function, but I actually have to import NumPy. So import NumPy as n, or import NumPy as np. I need to do np.zeros, and then the first thing I have to supply is a shape. I'm just going to use image.shape, and then we need a data type, dtype, and then I can just actually, image also has that, image.dtype. So we don't have to know any of these parameters. In fact, we just pass in what the image, pass in the information of the image as the arguments of this function. And zeros just creates this matrix full of zeros that have this specified dimensions and this particular data type. So this is, slightly a bit more efficient and memory conscientious than just copying the image. So, but if we run this, you'll see that it has, it produces the same result. It's just one is a bit more efficient than the other, and so we'll just be using that. So just to recap, in this video, what we did was we learned how to apply contrast and brightness to an image, and we did that using this addWeighted function, where the first parameter is first image, second parameter is the actual contrast. Then this third parameter, as I mentioned before, this is just kind of a better way to do it using a matrix full of zeros with the same shape and dimensions as our original image, and then the beta parameter is always 0, and then this gamma is a matrix, and then we don't have to actually create a matrix. OpenCV will do that, and it corresponds to our brightness value. So contrast and brightness applied with a single line of code in OpenCV, super awesome. So that's what we covered up in this video, and then in the next video we're going to kind of cover some more things with OpenCV.